Welcome to Introduction to Engineering Design. Today we're going to start talking about the first step of the design process. The design process that we're going to use has 6 steps. The first step is define the problem. The second step, generate concepts. Third step, develop a solution. The fourth step, construct and test a prototype. Fifth step, evaluate the solution. And the final step is to present the solution. We're going to go through the process going one by one to make sure we follow each step the appropriate way the first time we do this. Today we're going to focus strictly on step 1, define the problem. The whole purpose of define the problem is to make sure we know exactly what we're trying to solve. So the first thing we need to do is we need to identify the problem. And in our case, our problem is to design a wire-guided vehicle that's going to follow the wire for at least 10 feet as quick as possible. We want to validate the problem. So when we validate the problem, we want to make sure that we know who's trying to solve it, who needs it or wants it, and are there any prior solutions to the problem. Sometimes engineers will come up with problems that already have been solved. In that case, just give them the solutions to that problem and let them go on their way. We want to make sure that the problem is worth solving. We want to justify it. If there's no, as a designer, if there's no money involved in it, then that's something you might not want to worth solving for. Once we realize that we justified the problem, then we're going to list all the criteria and constraints. These are basically just specifications that are required. These can be given to you by the owner. These can be things that you have to come up with as the designer or the engineer. And they can also be defined by regulations and rules that you have to follow based on codes. And the last thing when we're done is to create a design brief. So we're going to go through this step by step as we talk about the problems that we have with our wire-guided vehicle. After we read our entry document, the first thing I ask you guys to do is to make a need to know list. So here's some examples of no's that I came up with as I read the document. The things that we know about our project is 1, we know the materials that we need. I'm not going to make the entire list of it. This is something that you can pull back up and look at if you need to. But they were examples of like paper clips, tape, and so on. We know we had to design something that went 12 feet in 10 seconds. We know that was only when we pushed by a fan. This is the fan that we're using is a basic box fan, and we'll have the power set on low, and the fan will be sitting just below the wire. Do we need to have some type of backup plan? Well, part of the design process is coming up with things that we test and retest over and over and over again. So that will be our backup plan. It has to be connected to a wire. We want to make sure we use our time wisely, and that we must build something and actually use it and put it on the wire. So these are all things that we know about our project. After we talk about things that we know, then we're going to list things that we don't know. So these are questions that we may have. Some of them are good questions, some of them are bad questions, some of them are about the project itself, some of them are more about due dates and everything else. We want to try to get to the point where we create beneficial need-to-knows. So try to dig deep into the project and really think about things that you have questions about. So here are some lists that we came up. Can we use anything else other than the materials provided? The answer to that is going to be no. How does it stay on the wire? That is up to you. You are going to be allowed to design anything that you want, any way that you want, as long as it stays on the wire. I will say you have to be able to take it on and off of the wire. You will not be able to feed it through the wire. The wire is going to stay attached to both ends of the building at all times. Where is the fan? The fan is going to be located on one end of the wire, just below everything. It will hang down just a little bit below the wire. So about the center of the fan is approximately about 1 foot below the wire. What materials are light enough to be pushed by the fan? This is something that you guys will have to experiment with. You'll have some time to do some testing, and as you do some testing, you can record your results and see which ones you think are light enough to be pushed by the fan. How does it work? Or how do I get it to work? Basically, you have to come up and create with some type of sail. The sail will then work to push the vehicle as it slides along the wire. When does it do? This is something I don't know yet. Normally we'd give this project a couple weeks to do in class. With everything that's going on right now, it might take longer, so we'll see when it's due. I will let you know before it is due. Do you need to use all the materials? No. You can use any of the materials that you have, but you are limited to only the materials that I give you. Do we get practice trials? Yes, you do get practice trials. As long as there's class time involved, you can test this as many times as you want. When we present, do we have to dress professionally? Uh, I'll answer that one later on. What tools can we use? You can use any of the tools that are in the lab. Most of the tools that you're going to be using is probably scissors to cut everything that you need, maybe some wire cutters to cut the paper clips. When do we start building? We're going to start building as soon as possible. Our job is to work through the design process. We'll be doing most of that virtually, and then from there on we can start building once you get your design. What is the size of the wire? The size of the wire is a little bit bigger than a normal wooden pencil lead. It's going to be hung across the building. I will try to have that up before you guys come back into class on Thursday so you guys can actually see the wire. What power is the fan going to be on? The fan's going to be set on power of low. This is something that will not change. Once we get in there, we'll leave the fan on low and it'll stay on the entire class period. How many points is it worth? It's worth 100 points. This is something that was found in the rubric, and it talks about the ways that I'm going to grade you. Do we describe the design process? Yes, this is something that we're going to end up doing. Your entire project is going to be based on, can you build the design, then also can you describe what you're doing. The majority of your points from this project will come from describing what's going on. What happens after 10 seconds? After 10 seconds, I'm going to stop it and see if it goes, and we'll measure it. We might do another trial run where we let it go as far as we can, but we'll see what kind of time we have. Can we take it off the wire? You have to be able to take it on and off the wire. I will not reset the wire every time, so you have to design a way that that device comes on and off the wire, and that is up to you how that happens. This is an example of a need-to-know list. A lot of you did not come up with that, and that's fine, but this is some things that I am looking for the next project. We really want to dig deep into to know what we're trying to solve. As we go through the design process, this first step really is trying to figure out what we're doing, how we're doing it, what are some things that we got to do, because if we don't know what we're trying to solve, then we can't solve it. Once we get an idea of what we're doing, the last step is to create a design brief. A design brief is nothing more than a document to help describe everything that we're trying to do. On the next slide, I have an example of the design brief that we're going to do. You will have a link to this design brief in Google Docs. I will put that on the agenda. This is the one that you're going to fill out. We will actually go through and fill it out in this presentation as an example for our wire-guided vehicle project. You may use this as an example, or you can modify it slightly to come up with your own answers. Here's an example of a design brief. A design brief tells you the following things: who the client company is. The client company is who's hiring you to do the work. In our situations, most of the time you can just put me down because you're doing this for my class. The designers are the people that are actually working. So you guys would be the designers. So as we go ahead and talk about this, I'm going to go ahead and type it out. So again, the client company, this is going to be me. So you can go ahead and put my name down. So we're going to put my name down. We're going to slide it where we need it to go. The designers, again, the designers are people who are actually trying to come up with a solution. And this would be your name. So you would type your name in here. You are the designer. So I'm just going to type you. You would obviously put your name in there. Come on. There we go. Okay, now the problem statement. What is wrong? This needs to be a complete sentence. So as we come up with a problem statement for a wire-guided vehicle, it can be as simple as we need to design a vehicle to travel 12 feet on a wire. Okay, this will describe what the problem is, and then sometimes we'll have a little bit more defined problem. In general, most of our problem statements are going to be very vague. As you get into real world problem solving, this is describing what is wrong, and we're going to put that in the problem statement, not on the design statement. Sorry about that. Okay. Now, the design statement. What are you doing to solve the problem? Again, we want to use a complete sentence on this. So, what are we doing to solve our problem? Well, we're going to, so I'm going to use a little bit different terminology, but we're going to develop a vehicle to follow a wire using only the materials provided. So this is telling us what we are doing to try to solve the problem that we were given. Again, we will have some problems that are kind of vague on this. We will also have some problems that are very defined as we go out through the class. But basically it boils down to is your problem statement is what's wrong, and your design statement is how are we fixing it. The last box is called the constraints. These are your requirements. These are very similar to what your no's are. So I'm just going to write a couple of them. I want you to expand on this, but definitely like our materials is a requirement. So you would go through and you would list all the materials that you need. Anything else that you have constraints of will go here. They do not only have to be the ones that I give you. They can be things that you come up with. Maybe you want your object to attach to the wire a certain way. That can be a constraint. Maybe you want it to look a certain way. That can be a constraint. These are all things that will go into your constraints. They're basically requirements for your project. Things that I give you, things that your client gives you, or things that you come up with on your own that you got to have as requirements. You want to fill this design brief out. There will be a link on the agenda, and you want to fill this out as if it's your project. Okay, the main purpose of the design brief is to be able to hand it to someone so that they know exactly what you're doing at any time. So if you have a new person to your group, or if a new client comes to you, you can say, here, this is what we're doing. It tells you who you are, who's doing the designing, what's wrong, what are you doing to fix the problem, and any requirements that you have to solve that problem. The last part of step one is to really make sure that the problem exists. In some cases, if the problem is not valid or justifiable, the designer must define a new problem. So if you come to a situation where you know you have a problem and you realize that this can't be solved, that's when you would go back to your client or you would go back to the designer and you guys would talk about, okay, this is not something that we can do. We need to make sure that we have a problem that you can solve before you begin. If there's nothing to solve, then there's no need to move any further. Next, we'll talk about step 2 on a later date.